Excellent. Thank you very much.
I'll come off mute now.
Yep.
Okay, all good. Can everyone hear me? Oh.
Yes.
Thank you. We're having technical issues. Yeah, all good, all good. Okay, thank you everyone for joining on Teams and for everyone in the room for being here tonight, and thank you to Jonathan and David for giving me the opportunity to present here. So this is the Drainage Innovation Solutions presentation for the PWI by Scott Purnell and myself, Jason Robertson, the rep of Scott Purnell. So the reason for the meeting and the presentation, CPD, whatever we call it, is that photo on the right hand side there, a river through the UK somewhere with a bit of track below it. It's a problem we're seeing more and more, especially up in Scotland and across England and Wales and Ireland as well. The drainage is failing, it's not been maintained, it's not been upkept, and we're hoping to change that. So with that, I'll be discussing some existing drainage products, the current rail market in terms of the testing requirements, some innovative products, and the product testing that we have got going on with the new and existing products. So quick background on myself, I'll fly through this because David gave a good explanation there. Jason Robertson, Drainage Spec Manager for Scott Purnell, joined last September, so about 14-15 months now, prior to which I was with Babcock and then the RSA Scotland for 15 years as an apprentice, so 17 until 32. And upon leaving, I was the infrastructure manager for drainage and associated civils. So part of the team that delivered the drainage programme over CP4 and 5, and when CP6 kicked off is when I got the promotion. So as part of that team, been involved in over 100,000 yards of trackside drainage projects, quite a lot. A big part of what I'd done with Babcock was working with other suppliers and manufacturers to spec and reduce new products, some of which are still being heavily used in the industry today, and it was a case of mass redundancies, time to leave and move on. In Scott Purnell, we're looking for someone to head up their drainage products, so it was a match made in heaven, a no-brainer for me. A big thing that I'm doing, as David mentioned, in my role currently is getting all the products approved and tested. We know pads isn't a thing anymore, and all products need to have individual testing. So most of, if not a great deal of what I'm doing is making sure our products are fully compliant with Network Rail's new standards in terms of the materials used, the manufacturing process, and the testing and design life. So Scott Purnell, for those who don't know, we're a massive merchant to the infrastructure sector, not as well known in Scotland, but certainly in England and Wales, a massive name. Two main branches to the business, Rail and Nationals. Rail speaks for itself, Nationals I'll come to in a second. Within Rail, we do have sector specialists, myself in the drainage, my colleague Joe in the south was 20 years as a civils site manager. We've got a Geos manager as well, and yeah, everyone within the rail team anyway must have a minimum 10 years experience, be that on site or in the office, planning, procurement, whatever it might be, minimum 10 years experience in rail. Innovative product portfolio, again, I've got a good slide in that in a bit. Collaboration with client and consultant groups. We're not just a kind of typical merchant that will sit behind a screen churning out quotes all day. We do like to see a product cradle to grave and get that early engagement with designers and straight through to installation and then eventual handback. Sustainability and efficiencies at our core. We're very humble in that. We're very transparent in what we buy and sell for. We are here to make money, but we're also here to keep the railway running and make it efficient. So with that, we are the main framework supplier to the CRSA, the SRE in London, and we've just been awarded the supply framework for the TfL London Underground. That was my first project when I joined, was to assist with the the tender for the TFL supply, and we won it. So I was really proud of that. Employee-owned trust, the two owners, Dave and Steve, sold the business back to the employees 2 years ago instead of selling out to a big PLC. So every employee has a vested interest in how the company does. And we're a medium-sized enterprise, so we turn over about 130 million a year. So the wider business, the national side, that's kind of makes up about 80 to 85% of the wider business of Scott Parnell. There's just a few ideas of the kind of wider side of the business outside of rail. National distribution, so as you can see in the photo in the previous slide, we do have branches up and down the country. We've got a full water management department, geotextiles and grids. We're one of the biggest suppliers and suppliers of geotextiles and grids in the UK. With our relationships, ICS, which is an independent civil solution company, which is an engineering merchant, Rowden Pipe Tech, another pipe and drainage merchant that we own. We've got a large energy and power department. We work a lot with Murphy Group up in the north of Scotland. They've got an offshore wind farm. Scott Parnell and SP Pipelines, which is a brand new business that we've brought into the family, which is a ductile iron business for water and utilities. And as I said, we've got a huge kind of standard merchant branch network. So the rail team, very small team in comparison to the wider Scott Parnell group, but we're all pretty good at what we do. So Sharon, head of rail, we've got Ian, the technical director, myself and Joe, the spec managers, and then below us the sales team. So very small team. So innovation, this is something that's really important to me. Something I kind of coined when I joined last year was the 4 pillars of innovation. Within the first few months, well, the past year anyway, spent a lot of time kind of trimming down our wider supply chain, cutting some companies out, bringing some different ones on, with the idea that everything that I will speak about in terms of drainage must fall into all 4 of these categories, not 1, not 2, 3, but all 4, which is reducing carbon, improving safety, reducing cost, and less of reduced maintenance. So that's kind of the key focus that I want our company to go towards. Supply scope, not really important for something like this, more of a kind of procurement thing, but just to have an idea of the wider offering that we can supply: walkways, aggregates, concretes, cable management, geogrids and textiles, general supplies, the one-stop shop for any rail construction project. Civils, I won't spend too much time on this because it's not in my remit whatsoever, and please don't ask me any questions on it because I don't really look after this stuff, but I'd just like to add some of the really cool stuff that we do in terms of civils. So Flex MSC, which is the bottom right photo there on the screen, it's a vegetated retaining wall system. Probably seen it before, it's quite popular. Essentially black, biodegradable Hessian style bags filled with organic mix. It's laid as such like that. It's then hydro-seeded, and then 12 months later it would be a complete grass verge, but also still acting as a retaining wall. So it's a very popular product, very cheap as well compared to post-mixing concrete. So it's really a no-brainer for a retaining wall. Technocrete, which is the left-hand side photo on its own, our alternative to post-mix or concrete, comes in 2 bags. So it equates to 1.8 kilograms in 2 separate bags. One of the bags is recycled cooking oil, the other bag's the chemical formula, and when mixed together it foams up a kind of green slime, and then within 5-10 minutes it sets, and once it sets it's stronger than C50 concrete. So it's a good thing for in terms of weight. So one bag that weighs 1.8 kilograms, once it foams up, it replaces up to 60 kilograms of concrete. So there's not that extra weight for guys working. No hazardous fumes or waste come off it. It's very green friendly. I say sets in 5 to 10 minutes. No water required. It's just the 2 bags, mix them together, and then it puffs up and sets, and that's it solid. So yeah, really good product. Touch Safe, the top right photo, it's a GRP fence. There's not much else I can say about it. There's no steel fixings and fittings. It's 100% GRP, touch safe, non-conductive fence. Arco Rapid Route, that's probably the most popular product that Scott Parnell sell as a business. The top left photo, the company was pretty much built on the back of Arco and Rapid Route, so very popular up in Scotland with SPL and Westland Group. Loads and loads of jobs going on with that right now. It's a steel pile, a steel anchor screw that's driven into the ground with a battery pack, built up with steel fixings, and then the ARCO system's laid on top. It's the only approved system for low and high voltage cables elevated at 6 metre intervals, and it can be installed under live OLE during line blockages, which is what we usually find with Westland. They'll do it day shift during line blockages, so really good product. And last one, the grip boards, bottom left, ballast retention system, GRP to replace concrete. 12 kilogram board would replace a 60 kilogram concrete board. These can go 1 metre high, and the king post can also be fixed with the anchor system. So the same idea, screw into the ground, build up with the king post, and then put in the GRP ballast board. So some cool stuff in the civil side of things. And then on drainage, I won't spend too much time in the standard stuff, if any time at all. I'll probably try and just fly through a lot of the slides in that. But yeah, just to give an idea of the wide offering, the full kind of package we can offer: twin wall pipe, solid pipe, GRP chambers, HDPE chambers, concrete chambers, concrete channels, which is the LineWorx, the smart ditch, and trench liner. So twin wall pipe, I won't spend long on this at all. Rail approved SN8 try that again. Twin wall pipe. We are in partnership with Polypipe. We're one of the biggest twin wall pipe manufacturers in the UK, if not the biggest. So really happy to be partnered up with them now. The bottom photos you can see there, the bottom two, the blue internal. That's the current version of, well, it was the current version of rail approved pipe that was called Rigidrain, made with 100% recycled plastic. The top right photo, the grey internal, or battleship grey, I've been told to call it. That's called Rigitrack. That was developed for the London Underground. It's virgin material. It's a lot more robust. We are working with them on testing right now. The way Network Rail standards now dictate the manufacturing process of twin wall pipe, it looks like that will be the standard going forward, is the Rigitrack. And Polypipe are the only UK company to have an in-house UCAS testing lab for twin wall pipe, so that'll be pretty good for us. So the new chamber, this is a Polypipe product as well they use in the utilities world, but I'm looking to bring this into rail. So it's a GRP chamber with interlocking system, the same idea as other manufacturers. But as I say, very popular in utilities, so we're looking to get this tested to the standards as well, upgrade it if required, and get it out on the market. They provide these solid with no holes cut for the pipe, and they would just provide a drill auger attachment for the pipe size that's specified. So from my background in installing, I'd be quite interested to see how the market reacts to that. Instead of having a chamber with the holes for the pipe pre-cut, you would drop the chamber into the trench and drill the holes yourself and then insert the pipe. So I'd be quite interested to see how people take to that. I'd be quite open to trying it. Coming 5 different sizes currently, but once we do have rail approval or testing, I'll probably narrow that down to 2, which will just be a standard and a standard CES and a standard 6-foot. Solid wall pipe we supply from MGS Demco. It's the same pipe that can be supplied by other manufacturers and merchants in the UK. STR 11 and 17. That's just the strength rating on them. We can supply perforated or slotted, and it varies different intervals, fully perforated, 1/3, 2/3, or just solid. It's got an integral O-ring joint, as you can see in the top photo there. The front part of the pipe shaved off, and that's mirrored on the other side. It's shaved off on the inside, and then it clicks together with a rubber seal, and once it pops together, it's essentially stronger than a rubber band seal. Designed for shallow trackside drainage and UTXs, 100% recycled and recyclable plastic in this. These can be installed 300mm below the sleeper in the CES and the 6-foot. We've got the testing data to prove that. Not in a UTX scenario, although it has been done. It requires RAM sign-off and an engineer to pretty much design it, but it can be done. So recycled GRP FlexiPit. This is from Cubis. We supply this, very popular product. Similar to the Subterra that I spoke about, GRP rings that are stacked together. The difference here is that it has the adjustable inlet and outlet plate, as you can see there in the photo. It can be raised or lowered with the arrows there. So how that works is there's wing nuts on each side holding that together. Once they're loosened, the plate can actually raise or lower at 150mm. So again, from my background in the installation side, getting the invert levels on the The chamber was always the most difficult part of the night. And unfortunately, it's the only part that could be checked afterwards at the handback is the invert levels in the chamber. So it could be a case of getting your level with the pea gravel, dropping the chamber in, realising it's 30 mil higher, 30 mil lower, whatever it might be, get the chamber back out, make adjustments, try again, try again. I say this without any lie, you could be 4 or 5 times per chamber on a shift in a rules of the route possession, which is holding up the entire job. So having that adjustability of 150 mil, as long as the chamber's in there to a certain degree of accuracy, you can raise or lower that pipe to hit the invert level, screw the plate back on, or not even screw it back on, just tighten the wing nuts and move on to the next one. Game changer. And standard with chambers, blue GRP hinged lid. So the flow pit, this is a brand spanking, brand new product, which is why I've only got CAD drawings here because we don't actually have a real one to take photos of yet. This was brand new. This was something I was tasked with when I joined to create a monolithic concrete chamber to replace standard and Matisse concrete rings, which is very popular the further south you go. So we came up with this, the flow pit. So there's 4 variations to it. There's 2 sizes, a standard size and a Matisse size for Cess or 6 foot. And within that, there's either a 2-way or a 3-way. 2-way being for a straight through drain, and then a 3-way for a UTX or a third party inlet, whatever it might be. So as I say, we have literally 2-3 weeks ago just had the testing complete on this to prove that it will last 100 years in the track support zone and it holds up the structural testing as well. So I'll go into it a bit more detail now. This is just on the 3-way standard model. So the sizes are 1150 by 1270 by 735. The front and back opening is 500 by 695 and the side opening 500 by 500. I will say I'm trying to change that due to the testing results that we got. Front and back slot, as you can see where the arrow's pointing to, there's a kind of notch cut out in the top. That's to allow for the L clip to fit in if it's just going straight to a GRP ring, a GRP lid, sorry. Or there's dimples in the 4 corners, you can see, to be built up with concrete rings if there's more height required. Or we can provide an adapter to go to GRP rings. So it's quite adaptable that way. It's certainly not modular. I don't use that phrase for it, but it's adaptable. The approximate weight of this is about 780 to 800 kilos, so there's a fair bit of weight in it. It is a machine lift. There is lifting hooks. You can see in the inside and the base that kind of dimple in the corner. That's just to mirror where the lifting hook will be. So there's 1 in each corner, 4 lifting points, and it would be chains or slings, whatever it might be, dropped into the hole. And with the idea being that once it's in the hole, it's never going to move. It's there for 100 years. It's going to probably outlast the railway itself. The apertures, so the entrances, obviously they're not fit for a pipe. So we took the idea from the Cubis catch pit and brought it to this. So these will be affixed with 20mm thick stone guards. Standard 8mm, we wanted to add more strength, so 20mm thick. Wing nuts in each 4 corner, as you can see in the photo, there's holes for the screws to go in. With the same idea that the plate can be raised or lowered a certain amount once it's in the hole for that pipe invert level. Because in reality, you don't want to be dropping this in the hole and then try to lift it back out because of the weight of it. So yeah, as I said, we used GGP consultants to first of all design and prove that it would work at a theoretical stage in terms of design life and structural testing. We then sent the 2 models to Lucidian, who are a UCAS lab down in Peterborough, I think. We were told by Network Rail that these chambers had to withstand at least 85 kilonewtons at a minimum. So we sent down the 2 weakest ones, with it being the 3-way models. There's less concrete involved, so that would be significantly less, not as strong as the straight through ones. So with the Matisse version, the first crack appeared at 136 kilonewtons, and on the standard 3-way, the first crack appeared at 196, and then failure was achieved. Essentially, the thing crumbled. On the Matisse at 665 and on the standard at 1310. So by a considerable margin stronger than what Network Rail asked us to prove. Hence why, if I run it back a bit, I want to extend the opening in the 3-way unit to allow for a larger pipe diameter to go in. I'm also thinking we can shave off some of the concrete. Certainly safety first and everything, but when we're achieving way over 10 times, almost 20 times what Network Rail have asked for in terms of strength, we can certainly cut back on some of the concrete used and some of the reinforcement, which for me, it just brings down the price. That's the only goal there for me, is to bring down the price, make it a bit lighter as well, and a bit more practical. And trench liner, I'll just fly through this. Standard trench liner, the same as can be got anywhere else, made in the UK. It's a white liner, so again, if I can touch on my background, the way we installed drains, the way we use trench liner, sorry, is we would have black trench liner, standard stuff. We would cut it in rolls of 10 metres and then fold it up and lay it every half cord. So once the trench was dug out every 10 metres, we could just unroll it and drop it in the hole, which logistically was a fine idea. But what you would then created is a dark mound on a dark environment, being the railway and rules of the route possessions. It was a darkness. It became a massive, massive tripping hazard. Many skint knees and trips and slips through that. So with this being white, it just has that extra health and safety benefit that it will contrast to a dark background of the railway. Tensile strength of 18 kilonewtons per metre, a static puncture resistance or CBR of 2900 newtons, and a permeability of 80 litres per metre square per second. It's much cheaper than the alternative as well. Smart ditch, this is a great system. Flexible thermoform plastic channel. It's got a ridge design for sediment control. So the standard stuff is what you can see in the top left and bottom right photo. And then the top right photo is what we call the additional baffle boards that can be added for extra sediment or flow control. UV corrosion resistant, so this will last 100 years in an outside environment, even in the harsh Scottish weather or wherever it might be. Very easy to install and maintain. These come in 1 metre sections. They're very, very lightweight. That bottom right photo on the pallet, there was about 100 sheets, we call it 100 sheets on that, and it was a 2-man lift into the lorry. Very, very lightweight stuff. And yeah, they just fit together. So the end of each ridge is a rubber seal, which allows the next ridge to pop on top of it, and it just holds it in place. And we would just recommend 2 self-tapping screws in each corner just to create a kind of mechanical bond as well. Various different shapes and sizes and adapters. As you can see in the bottom right, there is a pipe adapter to go straight into the system itself, but they can go in at a right angle, different pipe sizes, different, it's very, very modular that way. We've got full brochures on this stuff. Cost comparison, I really won't touch on this because this certainly isn't a sales pitch. I probably should have taken this out actually, but just to give an idea on because it can be quite eye-opening compared to the leading market competitor that we work against, the savings that can be made. So in twin wall pipe, between 10 and 20% depending on the size. Couplers for all pipe sizes, 20 to 25%. Solid wall pipe, 10 to 12%, and there's no requirement for the rubber seals because we've got the integral O-ring. On GRP chambers, 3 to 5%. On trench liner, 10 to 15%. Over a full 1,000-yard package, which is kind of standard drainage stuff, 10 to 18%. And over a 10,000-yard framework, which I believe my colleagues just delivered at Babcock, would be an annual saving of about 200k. So a lot of money. So LineWorx, the real kind of good stuff, and the reason why I wanted to get this meeting organised. This is what I call our champion product. By far and wide, my most favoured product. I absolutely love it. This is what I've got, the 3D model for those that are in the room. This is the LineWorx 3D model that cost me a pretty penny. But it's a visual aid. I always think a visual aid's better than listening to some guy just read off slides. So with that, I've also got a small video. This one will last 3-4 minutes, and this will give a good introduction to the system itself. Okay, so as I say, the video does a far greater job of explaining and introducing the product than I could ever do. And as I say, I've got a 3D model here in the room, which gives an idea into it as well. So the beauty of it is, and as the video demonstrated, the modular build does a lot of different parts and adaptations to it. So although it is just a kind of single concrete channel, it can be raised or lowered. There can be sump units. There's different shapes and sizes to it. Very easy to install and maintain. We usually find that installations, depending on the invert levels, are double as quick as standard pipe and pit, just due to the reduced excavation. Is very easy to install. Maintenance wise, that is a real game changer in that it can be fully inspected from ground level. And by lifting the lid, you can see the entire channel from top to bottom. So there's never any need for CCTV or heavy jetting. It can be viewed from a maintenance inspection point of view. Access both flow and attenuation, so it's a real flood prevention system as well, with the flow through the base unit, and then for each intermediate or riser added, there is that extra attenuation as well. Superior hydraulic capacity compared with pipe. I've got a few slides on that due to the testing we've had done recently to prove. Reduction in catch bits, so yeah, we don't have to tie into catch bits at all. We do have some units, they're not in the animation, but they're in the 3D model, kind of L-shaped some units, and I've got some design photos of them later on in the slides. Concrete or blue GRP lids, we get asked the question, can we go full concrete or can we go full GRP? Is there any kind of standard detail? There isn't. We usually see a blue GRP lid every 30 metres just to mimic that kind of traditional inspection zone. EPD certified, so obviously it is concrete. It's made with low carbon concrete. It does have an EPD certificate, so we can prove exactly how much carbon is used to manufacture it. And it has got a 100-year design life. So we have commissioned the lovely people here at Arcadis in the past year to prove the design life, the structural capabilities, and the hydraulics. We're very, very 99.9% close to getting the reports through. We did have them done, but we've then added some additional parts, which I'll touch on in a second. But they have proven the 100-year design life due to some amendments we've made to it, and installation 150 millimeters from the sleeper edge in certain scenarios. So the system itself, as the video showed, is quite a simple design, although it is very innovative. There's the base unit, the intermediates, or the risers, and the lid. And then there's the tapered and half risers to mimic the natural lay of the land if it has to be raised or lowered and sloped. Weights and dimensions, not really too important, but some of the times the questions we get asked, how is it installed? Is it a manual lift or is it grabs? So yes and yes. We usually find with case studies in the companies we deal with down the south that for a 100 or a 300 series, it would be a manual lift. There's not a great deal of weight in them, although they are concrete. They're very, very easy to handle and move about. Once it gets to a 600 or the new size, which I'll come to in a minute, it would then be a grab lift. So with that, the LineWorx grabs, these are Lola approved lifting grabs. They can be used for a single channel or a double channel, as you can see in the photo there, stacked side by side. A lot of the time, the companies we use down in round about London, instead of installing a 600, they'll install 300 side by side. It's just a bit easier to manage on site, and the hydraulic information is pretty much the same. So these are spot hired by ourselves. So that's a kind of standard install. It's not too dissimilar to pipe at all. It's a narrower trench, a shallower trench as well, I should say. We usually find the sweet spot, and I'd say 80% of the designs we get through are 500-600 invert levels, compared to a pipe 1.3, 1.5, whatever it might be. And then it's just a simple bed of gravel to set the channels so it's kind of flat. Geo trench liner surround, hopefully white rather than black in that scenario there on the photo. And then, yeah, just build up, backfill with ballast each side. I know the video had pea gravel up the sides, but a lot of the time we get asked, is that really a requirement? Can we just backfill with ballast at the sides? There's no standard detail on this, so ballast around the sides would be absolutely fine. There's no issue with that whatsoever. And then, as I say, GRP lid every 30 metres is the kind of standard go-to. Case studies, I've got slides and slides and slides and slides of this stuff, but I would be here until tomorrow if I was going through them all. So I've just took a few snippets out of the case studies. So Harbury, that was a good one. That was 87 metres through a tunnel and a network rail job. I've got a photo of it in the next slide, but essentially it's a track goes through the tunnel. Due to the cobbling of the tunnel wall, they couldn't get it low enough to get pipe in that would be compliant, so they moved to LineWorx. It was base unit, 2 intermediates, I believe, and then the lid, and that goes the full length of the tunnel for 87 metres and into a drainage outfall. Back to north, ongoing DLR, that's probably our biggest project for LineWorx currently. There's hundreds and hundreds of yards going in there. It's just an ongoing thing. We get new designs through quite often for new specification and new orders. Ruislip and South Harrow, both London Underground projects. It's a really, really big product for the LU. It was made for the LU, I probably should have said that. It was designed for the LU back in 2012. And it's one of their favoured products. And then Mark Beach Tunnel, which is a network rail BAM job. So a few photos there from left to right. South Harrow is the one on the left, so it shows how adaptable it can be in very kind of narrow conditions. You would struggle to get a standard drain in there with how close it is, and the 6 foot and with the third rail there, whereas this is fully compliant to be installed in such a scenario. And in the middle photo is the Harbury Tunnel one I spoke about, so very close to the edge of the wall, very narrow due to the cobbling of the tunnel wall. Perfect scenario for that. And then back to north, as you can see, the 2-300 side by side, and it just goes for as far as the eye can see. There's lots and lots of LineWorx in there. And then this left and middle photo, that's Mark Beach Tunnel. Again, just a standard tunnel one. Couldn't get the pipe in due to the wall mouth. It's a circular tunnel. So similar to the mountain tunnels in Edinburgh, where this would probably do a good job. Or the Haymarket tunnels. And then Harbury again on the right hand side. That's just showing the LineWorx then outfalling into the I think that's a Cubis chamber. So to give an idea, so the further north we go, especially in Scotland, it's not really a known product yet, but it's certainly not a guinea pig trial product. There is over 20 kilometres or 20,000 metres of it installed across England really right now. Mostly in the LU. I think there's 17,000 metres in the LU, and then the rest is network rail and DLR. But just to give an idea of the companies we work with, definitely our biggest client and partner with LineWorx is Transport for London. I'm in with them every couple of months, which is great because I love going down to London. Just doing the spec design on that stuff, and then On-Site, which are a big design design company down in London. They're the alliance partner for the SRE, the Southern Renewals Enterprise with Volker. So some really big names in there. And as I say, we are looking to see it specified more and more further north in central England and Scotland and Ireland as well. So standard design, I've got files upon files of this stuff that I can send across if people are interested of how it is designed in relation to a track. It can outfall into a chamber, as you can see in the photos there, or it can just act as a kind of standalone drain on its own with the sump units. and then on the right hand side, excuse me, shows how they would sit side by side in a design scenario. So new parts and accessories that I wanted to add in. So the grated lid, that is blue. I just did the CAD file, which is grey, but it actually is blue. So that's just to show the grated lid, which I'll probably get a 3D print for as well, just to add to the model. As the video showed, we can transition to pipe through stainless steel plates, as you can see in the middle photo there. Or if it's the end of the run, could just be a steel blanking plate. Some units, so again, that's just a CAD photo because we haven't had that finalised with Arcadis yet, although we've been promised we'll have it before Christmas, so within a matter of a week or two. Essentially, it's just a base unit, but it's extra deep, so it would act as a kind of natural catch pit sump, which would replace the one that I've actually got in the 3D model. Instead of the two different parts, it would just be one solid unit. And then the 450 series, so the product itself has three sizes, 150, 300 and 600. We're now introducing a 450 just to bridge that gap between the 300 and the 600 because number one, it's a massive cost element going from 300 to 600 and the actual hydraulic capacity is far greater as well. So we wanted to bridge that gap in the middle. So as I said, we've been working with Arcadis for the past 8-9 months just to get the product approved. So we had to change the reinforcement from mild to stainless steel, which we've absorbed the cost on that, thankfully. We've made a few other amendments to the actual design of it. As I say, we've changed out the sump units and a few other things. We're now very happy to say that it has been proven that it will last 100 years in the track support zone. At sub 15 miles an hour, sorry, I'll try that again. At sub 15 mile per hour line speed, the product can be installed 150 mil from the sleeper edge, so that likes of in tunnels or undergrounds or really confined spaces, it can be installed that tight. 15 to 125 mile an hour, it can be installed 500 mil from the sleeper edge, which is still very tight. There's no limits on that. If it's a very, very tight radius down the West Coast Main or whatever it might be, 500 mil, it will last. And then that's just a kind of table showing how Ruth Platt of Arcadis has been working on it and proving the structural capabilities. And again, I won't spend a whole lot of time here on this. The left-hand side there is just the different shapes and sizes and variations of the product. And then the second one is just the distance from the sleeper, so 150 or 500. But the thing to focus on here, for me anyway, is the two right-hand columns, which as you can look all down them, is pass, 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 pass. So the actual structural report itself is right now it's about 800 megabytes. So it's not even one Dropbox, it's two Dropbox to share that with people, but you can certainly share it anytime, it's not a problem. They've also calculated the maximum permissible load. This was a request from the CRSA for us to prove, so they've calculated that as well, which will be in the final report. But we are going to get some physical testing done early 2026 with Lucidian, who were the same company that tested the flow pit. And essentially just be a crush test. So we'll have different variations, different heights, different widths, and they'll just destroy it effectively, and then we'll get an accurate maximum permissible load, which will then be added to the Lucidian report. So looking forward to that. On the flow, again, I've got a full hydraulic report from Sue Brocken of Arcadis, which I've extracted a few numbers from. I won't get through too much because I've just realised the time and I'm starting to waffle. So I'll just pick one. So the 300 tall base, that's probably the more popular product, and that's what I've got the 3D model of, the 300 series, at a slope of 1 in 250 standard drainage gradient. The 300 base on its own would provide a flow rate of almost 60 litres per second, 58.9, and that's just through that one base on its own. And then adding in between 2 and 6 intermediates. So the way they model it is you've got the flow through the base, which is just a simple Manning's equation. And then for each intermediate added, that provides, as the water builds up, that would provide a head of water, which would force more through the base itself. And also, as you can see there is kind of little letterbox. You can see them on both sides, letterbox openings flow through there as well. So they've done a kind of flow, how that would all work together. Again, it's a big report we've got from them, but I've just took a few snippets from it for this table, just to show some of the benefits of the flow compared to pipe. And on volume, as I said at the start, the benefit of this is that it provides both flow and attenuation for flood prevention. So there is a massive, massive volume of water that can be held in each individual unit of this. So I'll go again with the 300, with it being the 300 tall base with 6 intermediates, an internal volume of 250 litres. So they're just in 750 ml section. So effectively, this one right here, if I don't break it, that on its own with the base would hold 250 litres of water, which is the equivalent of a 700 to 750 ml pipe. Now again, my background installing drains, over 100,000 yards of drains installed. Not once have I ever installed a 700 or 750 ml pipe in a cess. It's just not possible. The most we've ever done is a 450, I believe. So having such a compact system, which is 300 ml wide, which can have that kind of attenuation in it, excuse me, for flood prevention, it's night and day to what a pipe can achieve. So commercial, again, it's not a sales pitch, so I won't go into each individual part here, but one of the first questions we do get asked is, how much is it? Must be expensive. And yes, it is very, very expensive. It's about 4 times the price of standard pipe and pit on a project, but there are massive, massive benefits in terms of installation and how that can then claw back the kind of initial cost. So on a 1,000-yard drain, standard pipe and pit, which is on the left-hand side, twin wall pipe GRP, a standard 1,000 yard would be about 70 grand, whereas LineWorx would be about 300 grand. So yeah, I like to get that out of the way early and get the shock factor gone. It's very, very expensive, but it's concrete with stainless steel. It's not plastic. It's not recycled stuff. It's like the equivalent of going out and buying a 20-year-old banged up Fiat Punto or a 2026 Mercedes G-Wagon. It's a completely different product that's going to offer a different aspect. So labour, as I said, production time we usually find through case studies. So if with the SRE and the TFL, the production time is halved at the least. Installing LineWorx, that's just because of the shallower excavations. We usually find that LineWorx installed 500-600 mil inverts, whereas pipe is 1.2 to 1.5, sometimes even more. So the actual installation time is halved. A lot of people think that's a lot of rubbish, but that is true. So there's an initial saving of labour there, and standard drains 56k to LineWorx 17k. On plant, it's just a 50-50 due to the halved production time, so 84k down to 42k. These are numbers I just took before leaving my previous role. I realised they change depending on the company, the contractor, where you are in the country. In London, you can add a 0 to every one there. Access arrangements, so taking into account possessions, isolations, engineering trains, over 10 shifts for 1,000 yards would be about 185k. Access for LineWorx just halved, 93 or 92.5k. Maintenance, as I touched on, LineWorx will never ever require CCTV or jetting. It's all maintainable from ground level using shovels or spoons or hands. So we know that all drains, standard pipe drains, must have a 2-yearly maintenance regime of CCTV and jetting. Whether it happens or not, it's not for me to say, but we know that that's what's recommended. And then a 60-year replacement. I've yet to see a twin wall pipe and pit that would last 60 years in the ground. But for argument's sake, we'll say what Network Rail deem appropriate, which is 60 years. So a replacement for pipe and pit would be 380 grand. That's not taking into account inflation, probably 3.8 million in 60 years' time. Whereas with LineWorx, replacement 0, because it will last 100 years plus. So the initial 10 cost of a standard pipe and pit, taking into account the cost to buy the product, then the installation, the labour, access plant, blah, 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 and maintenance would be 590k, whereas with LineWorx, a 10-year cost would be 530k roughly. And over 100 years, and I know no one gives a damn about 100 years. I don't care about 100 years, but it looks good, so I keep it in. The cost of a standard drain, 2.8 million, whereas LineWorx, 1.2 million. So yeah, there is that initial cost up front, which is gargantuan compared to pipe, but it's a completely different product. It's far, far better in every single way, and over time it will, it's an investment. It will last the test of time and provide greater benefits on site. Just some other logistical benefits which we can't really put pounds and pence to. So as I say, it reduces a lot of staff on site and access itself. So key staff pressures, ESs, training staff, site engineers, health and safety people, people in the office, permits, access booking, the planners, development meetings, no requirement or lacking requirement in temporary works if it's less than 500 mil deep. There's not really a requirement to put in temporary shutting, so there's savings there too. So really, it frees up a lot of resource to work on other projects or, God forbid, get some time off in the railway. And yeah, welfares and site compounds too. Short-term rents and third-party grounds, which I know firsthand is crippling for the Alliance anyway. And then transport, less vans on the road, less fuel consumption. So carbon, when I joined Scott Parnell, I came up with this equation, which I've got, and I'm keeping it very sacred, of the carbon that's offset for an excavation during a drainage installation. This was a lot of kind of deep diving in the internet and finding out different reports and different studies and taking into account the carbon that's offset from breaking ground, excavating ballast and soil, transporting waste and engineering trains, the fumes coming off the engineering trains, fumes coming off RRVs, and yeah, I kind of got this equation that I've got. And I put LineWorx against traditional methods again over 1,000 yards. LineWorx 150 at a depth of 500 to 600 to standard twin mil pipe at a depth of 1.2, 1.5. So I used my equation and it came back with a carbon saving of 62%, which was 49 tonnes of carbon per 1,000 yards. But I then said, well, I don't know what 49 tonnes of carbon is. That means nothing to me. So I put that to Google. What's that the equivalent of? And that bit at the bottom there, the equivalent of driving a diesel car at 170,000 miles is the carbon saved by using LineWorx over standard pipe. So as I said, we are very, very close with the TfL. They're probably the biggest, well, they're definitely the biggest partners for LineWorx, with it being developed for them early 2010s. There's over 17,000 metres installed across the LU, constant ongoing. I've got 4 different projects going in next year, so that hoping to go over 20,000 metres installed within the next 2 years. And we asked them for some testimonials just to kind of prove the maintenance stuff that I'm preaching about. And testimonial from Len Jenner, who's the drainage construction manager down there in TfL, gave us the following. In reality, at present, the LU maintenance teams are doing very little to maintain the channels installed to date, apart from a few specific instances where the channel is getting silted up. So that's in the London Underground, where, you know, it's oil, silt, muck, all manner of the other word that I won't say professionally, but yeah, you can imagine the state of the track down there in the LU, and they're essentially saying they don't need to maintain it. It's self-cleaning. It looks after itself. It does its own job. So as a very, very quick conclusion to LineWorx, as I say, we can prove that it will cut production time by at least 50%. So there's a saving on possessions, haulage, backfill resource, installing at a depth of 450 to 500 is comparable with a 1.2, 1.5 metre drain. Superior inflow and discharge in volume. It's a completely different product in terms of that. Mitigates the need to have labour in the trench because there's no need for temporary shuttering, depending on the depth, or it can be installed with the grabs. Reduced maintenance and long-term repair and replacement, and yeah, in lieu of installing traditional drainage, can reduce overhead costs by 50%. And just as a conclusion to Scott Parnell, we are an innovative rail merchant. We like to do things a bit different with our sector specialists and driver efficiency and sustainability and providing technical support. And something I say every CPD and presentation I do is collaboration. And I've got a kind of inventive brain. I just want to go out and make things and see it out there on the railway. And I say to all the people I speak to, if you've got an idea for a drainage item or a civils item, I don't care how wacky and well that is, come to me, I'll get a manufacturer to make it, we'll trial it, and if it's worth the time, we'll put it through testing. We're always looking to expand, and I'm always looking to just speak about different products. It is my passion. They say if your passion is your job, you never need to work a day in your life, so I love it. So we believe we could be the future of rail drainage. Oh, no, I went too far there. So final slide, this is something I've added in. I took it out yesterday for the thing, but we have an affiliation through myself with Andy's Man Club. I don't know if anyone's ever heard of them. It's a men's mental health charity. I actually work for them voluntarily. Second job, it's a suicide prevention charity with over 330 clubs in the UK. Closest one here would be Kelvin Hall, where you would find me every Monday hosting. Average attendance 67,000 men every Monday. It's free and anonymous. The railway, as we know, can have serious mental strains, and I'm luckily a survivor of just how bad it can get in the railway. So thanks to Andy's. So I like to just spread the word about the charity themselves. And Real Live next year, we're actually going to have a stand on our stand. Scott Parnell, a collaboration with us. So I'm really proud to be part of the charity. And that's me. 3 minutes to spare. Done no bad. So yeah, thanks very much for everyone in the room and everyone in Teams. Question wise, Davey, how does it work? Do you want me to read them out, or do you want to read them out? What's easier? Yeah, then I could give me a second to think and answer that. No, thank you.
Excuse me, not possible to hear you online. Can you direct towards the microphone?
No, I'm not mute now. Because you're over there. I'll mute.
Yes, a minute. Microphone.
Who's that? Can you guys now, Tom?
Yes, that's good.
Cool. I was just, what I was saying to Jason was, I was just wondering if it would become an attractive walking route. And if so, you know, I know you said it could be different materials on the top, but Jing that introduces different risks. It looks a brilliant place. I would probably be drawn to walk on it if in a 6 foot. I was just thinking, you know, is that like a collapse issue if it was made of one thing, and a slipping thing if it was made of another?
Yeah, so the lids are coated with a non-slip coating. Effectively, we cannot legally advise to walk on it, because if you're walking a trough foot and you fall in, you're falling maybe that much. If you're walking on that and you fall in, you're probably breaking a leg at best. So we definitely do not recommend walking on it, although we know, I'm a realist, I know people are going to walk on it. Which is why I think the blue lids are important as well, because then if you're walking along and you see down and it's, you know, a metre deep or whatever else, you're maybe going to think twice about walking on it. But yeah, they do have anti-slip coatings, but there's no real mechanical bond between the lids and and apologies to everyone in the thing I'm showing them the 3D model. That's how they fit in. It's just kind of slotted in that way and then fits in. So there's no screws or anything holding it in place. So we certainly cannot advise to walk on it, but
Yeah, sure.
we know people do walk on it, so it does have an anti-slip resistance on top.
Cool. Just one other wee one, probably a bit of a daft one. So I'm thinking of 2 tracks and that being in the 6 foot.
Yep.
Do you think, what about cross-track cable management? Because I know in the track you've got all the sleepers, etc., but there's still cables run across 6 foot currently, and now would be crossing a unit. I mean, I don't know. Nothing immediate jumps to mind, but just thinking, you know, for maintenance, lifting them off and then you might burst a cable or something because it's straddling it or whatever.
Yeah. I mean, if it's a surface level cable, then it would just need to go over the top of it. There's not really another way. And what we find, and again, we can't tell people to do this because it can impact the structural, but if it's a subsurface cable, just say, for example, there's a cable going through here, people would usually use a saw and cut a notch out there and a notch out there, let the cable go through and then build up. So again, it's not something we can advise on because shouldn't be cutting it really, but in reality, that's what happens.
Maybe you can develop a wee grooved lid for cross-track cable points.
Aye, well, it's something I can feed back, if that's something I can do.
That was magic though. I was really impressed with you. Thanks for that.
Jonathan, have you got any questions? I've got a few questions from online.
Yep.
So Tom Wilson's asked a few questions. So firstly, the new standard Battleship grey trap drainage pipe, rigid pipe, can you confirm that this is made with virgin rather than recycled plastic?
Yeah, Ridgey track. That's the battleship grey. Yeah, that's fully virgin material. It's much stronger, much more robust. That was made for the London Underground. They're a bit more stringent in their pipes. And yeah, as I say, to conform in everybody's new standards around twin wall pipe, it's looking like that will be the new standard pipe in the market, which I don't believe other manufacturers can produce. So the rigid track, the grey one, will be the new standard.
Another one, the 150mm adjustable catch bit chamber. Does this idea not potentially reduce the capacity of the sump to capture silt?
Yeah, well, the idea would be that you're not actually moving it on down 150mm. There still needs to be that degree of accuracy. It's not just a case of chuck it in the hole and then, yeah, 150mm is quite a lot. So yeah, there would still need to be the sump there. So I believe the sump must be equal to or greater than the diameter of the pipe. So there would just need to be that check before, unless you're raising it up, and then it doesn't really matter. The more sump, the better. But yeah, you still need the minimum pipe diameter for the sump.
Yeah, I think you touched on it when you put on the cost comparison versus a pipe system. You said £0 in terms of maintenance, but the silt's going to find its way somewhere, and it's the idea that it will be caught in the subunits completely, or
yeah, either caught in the subunits or to the eventual outfall, whatever that might be. But I say the maintenance regimes, and I don't add this in because shouldn't really be doing it, but the maintenance regimes for the TfL say that because it is shallow, they don't even use spoons, they just pick it out. You can't tell people to put their hands down a hole and pick muck out, but yeah, they just, the sumps are every 30 metres, or whatever they might be, depending on the grade, and they'll just either wooden spoons or put their hands down and lift out any muck.
Okay. Question on this, the smart ditch system.
Yes.
It says the ridge design controls sediment, which is great, but does this design shape not make sediment removal more difficult?
I've not been asked that before. Sediment removal.
So
I suppose, yeah, it would probably, yeah.
So we back up behind the
Behind the baffle boards, yeah.
Yep.
Yeah, it's an instance you would only have the baffle boards if there's that. If there's that requirement, if there's a very, very silty site, you want to kind of put a lot through the outfall, but it's just, if it's going from, say, the smart ditch into a standard drain or a sewer, then you just let the silt, you just install a standard smart ditch, you know.
Wee question on the, I think this is moving on to the LineWorx.
Okay.
So, the video showing the 6 foot drain, says the video showed a nice clean vertical face on the channel in the 6 foot, but that doesn't tend to look that way in reality. Could you comment on that, please? I think it's the idea of an excavation being as clean as that.
Oh, right, so I think you meant a clean face of the channel itself. I was going to say that. It's very clean. It's very, quite a good quality control. I mean, well, I would say, yeah, you're not, if you're installing, say, in fact, no, it wouldn't be the 300, if you're installing the 150, you're not going to excavate 150mm wide and hope that it just slots in. You still need to have that kind of buffer. So it's no different from what we done installing pipe. If we installed a 300mm pipe, your dig would probably be 450, 500, maybe even longer, wider. So yeah, I know the video just shows a kind of flat surface. Maybe cut cost somewhere. Yeah. So yeah, it would just be a case of digging as wide as required to get the channel.
So deep that is a wide enough to be
excavation. Yeah. The kind of V shape. Yeah. But they're not very deep anyway. The deepest one I've ever had is a metre. So I mean, they're really not built for deep drains.
Right. Okay. Does the installation of LineWorx still allow ballast cleaner activity?
I was going to start. No. Well, depending on how close it is. If it's 150mm, the sleeping edge, then yeah, it would impact the ballast and the ballast cleaner and the tamping. Again, that's if it's 150mm or within that kind of range, it is a RAM sign off. I think anything less than 4, I could be wrong, 400 or 500 must have RAM sign off. So it is for places like tunnels and undergrounds where you would probably see a lack of activity in that. Whereas if it's in a standard area,
although I'm saying it can be installed 500mm, that's not like it must be installed 500mm. Go as far out as reasonably possible, and then it wouldn't impact with a ballast camera. But yeah, if it's installed in a narrow 6 foot or a through S&C or through a cutting or a tunnel or underground, then it is going to impact that.
I think I probably know the answer to this, but how difficult is it to convince project funders that the increased capex for installation compared to a pipe will provide an MVP solution based on the whole life cost?
With the further south we go, it's really easy. Really, it's it's not even an argument. They just they have a requirement for it. It's specified, but it's something they've known and installed for over 10 years. Up here, a bit different. People still like pipe and pit, and I always say if you're working down the GSW and you've got a big wide session within 1.5 meters, 2 meters, and it's nice ground, put a pipe in. I'm not going to try and be a snake oil salesman. Like, that's always the way to go. But yeah, it's trying to change the mindset up here and I'm not trying to insult people up here because I'm from here, but change the mindset of our products out there. So I've been in with the RAM team, been to the street a few times. They're big fans of it. From last I spoke, it is being specified 100% in Perth, which is next year, early 2027. John Rutherford has confirmed that 100% be installed in there. There's also an ongoing design for Dundee and Dock Street, which I believe is with Atkins right now, but might be going to the Alliance. So that might be one for you to look at actually, but there's a concept design for it already. But yeah, as I say, people just look at the initial cost and go, no, absolutely not. That's Jesus Christ, that's scandalous, which I get because I'd probably say the same. But yeah, if you break it down and you see the cost, and I realise it comes out of different pots sometimes, the cost to buy to the cost to install, but that's where I think the Alliance would benefit, because although there is different parties, should be one pot that covers every aspect of the install.
Even though you've demonstrated that the whole life cost is going to be a benefit, I still think there might be a perception that it's for problem sites, and such as the tunnel that you showed, really constrained access width. But have you come across that sort of perception? Yeah,
I think that's what it is as well. I wouldn't say any standard drain that's just to catch some surface water and rainwater that's to use, because it's a weird thing to say, but it's too good for it. You know, it adds too much and it costs too much. If it was the same price as pipe, it would run up and down the length of Great Britain, you know, if it was the same price. But I think one thing when I first seen it, when I joined, and I don't know if I spoke to yourself, David, but I spoke to Paul Carrington very, very early days, and I showed him this, and we both said the exact same thing, Haymarket Tunnel, which was the Festive job prior. And I don't actually, I think I left by then, or I was off, but I can't remember what actually happened in it. It was the pipe that ran alongside the track, but that would have been the ideal solution had we known about it. And the likes of tunnels, so there was another one, I can't remember who was on it. It was another tunnel down in GSW, and the track, it was just an open trench next to the track. I meant Moncrief Tunnel, aye, that's it. We were looking at going from different pipe sizes and different widths, and it was okay to sort of more than the hydrology. That was another one. Paul said we could have maybe used it in there. Again, I don't know what happened to that job. So yeah, it's a niche product for specific sites, undergrounds, tunnels, tight cuttings. Well, this could have been used a lot. I think would have been Dundee, Aberdeen. We've done thousands of yards up there, and it's all rock. You're getting 500-600 below the track, and it's just bedrock. So that would have been an ideal scenario, and that's the one I've got one in Ireland next year, Ballymena. Similar idea. The track's in a very, very deep cutting, and they've done trial holes, and they're hitting rock at 500-600 below the deck. And there's 1,000 yards of that going in. That's already been agreed with WSB, so big win for me. So yeah, I'm not expecting designers to go out and just start putting this in everywhere, because it would just bankrupt the railway. But yeah, for niche sites, that's where we'd really want to see it specified. Through platforms as well, that's a good one.
Just to make sure I've caught the slide right, you were saying about obviously 100-year cost, and you mentioned about, obviously no one really thinks of it in terms of 100 years. But did I catch the slide right when it was saying about the 10-year cost being comparable with traditional drainage?
It can actually be less.
Slightly different, slightly
Yeah.
less, I think it was.
I'm kind of transparent. I'm not very good at the job this way. I've cherry picked numbers that suit my argument.
Right.
I have done that, and I'll be open and honest with that.
Right.
I know that maintainers aren't CCTVing a drain every 2 years. And that's whoever's fault that might be. It's not maintainers' fault, it's budgets. But yeah, I've cherry picked that to help the argument. But the installation side can really claw back in terms of the manpower, the resource, and the possessions and isolations and all that. That's where the real saving can be made.
Yeah.
The product.
So there's potential for that 10-year cost to be not a massive million miles away from what it would be for traditional drainage.
Going by the slide I put in, it's actually cheaper to install that. But in reality,
But taking into account obviously the CCTV,
Yeah,
talking
yeah.
about the 2-year net.
so we can cherry pick numbers to make an argument soon good, can't we?
Yeah. Thanks.
Another question. This one's on sustainability from Tom again.
Okay.
It says the carbon comparison arguments currently fail to convince network rail engineers that steel sleepers are more sustainable than reinforced concrete sleepers. Do you believe that similar arguments for LineWorx will be more convincing?
And just in terms of the carbon, honest answer, no. I don't think that's going to make one bit of difference to someone's decision making. It's nice to put in there, and it's nice that I can show there is a saving. But again, if I'm being totally transparent, which I'm guilty of doing, I don't think it's going to make one bit of difference to someone making a decision on that versus a pipe.
Yeah.
I could be wrong. There could be some eco warrior out there with a big budget that wants something. Please send them my way. But yeah, I can't see it making a massive difference to the decision.
Any more questions? Anybody online want to add anything or come back on any response? Thank you very much, Tom, for your questions.
Yeah, thank you.
No problem. Glasgow's always a hard gig. Oh, you did well, Jason. Well done.
Thank you.
But, yeah, I don't think I've seen this product before, so it was good to see it. It's definitely something I'll pass on to the drainage team. I don't know how many of the people in the lights have seen this. You said Paul had seen it already, but
Yeah, Paul's seen it. The other Paul Coyne, he likes it as well. He was speaking about getting me in early next year to talk about it. Who else? No, that's it. Really.
yeah, I've definitely not seen it on the site. Makes sense what you were saying about it's not made its way up north yet.
No, it's not been installed in Scotland yet.
Yeah, it's going to be good to, if it's going to be going in Perth, I'm sure get involved in that. So it'll be good to see it up north of the border.
Well, I say, with the Arcadis, they've done all the modelling for it and the redesign and everything. So I've got a kind of, not a gentleman's agreement, but we have kind of agreed with them that we'll be our design partners going forward for any changes or anything. But with that, we would like them to kind of push it as well. Arcadis have a much more wider range than I do as one guy. So we have got that kind of agreement, a handshake agreement that they will push it as much as they can as well. So hopefully we'll be seeing it more and more.
Nice one. Well, thanks again for your time, Jason. And,
No, thank you.
Jason, we round of applause for. And thank you for those who joined us online as well. Enjoy the rest of your evening. Cheers.
Thank you.